This section we are going to talk about a common SQL operation, nested query. A typical division type query involves three relations transformed from a binary many-to-many relationship. There are three situations here. My classmate might have introduced the previous two situations, so here we're going to talk about the third condition. The relation transformed from the relationship should be in the innermost query. For this case, we have an exercise that find the name of those projects managed by Smith that are participated by all employees age under 40. There's an ER diagram of this exercise. Employees work projects, and the EID and the project number is the key for the attributes. We could transform it to a relation and we could get three tables. Employees, it contains employee's ID, employee's name, employee's age, and employee's salary. And project table, it contains project number, project name, project, and the manager name of the project. And we get a relationship names works. And the EID and project name are the foreign key of the relationship. We could solve this problem step by step. We could look from the back to front. So the first step, we could find all participated employees whose age under 40. So the operation is select from employees where age under 40. And the second step is that we need to find the projects whose manager is Smith. We could say select project name from project where manager name equals to Smith. Finally, we could combine the above two steps to obtain the result. The query you need to solve should be the most outside layer. So the operation would be select name from project where manager name equals to Smith and not exists select from employees where age less than 40 and not exists select from works where employees EID equals to work EID and work project number equals to project number. For the next semantics is to make sure that we could relate it to every employee who did these projects. For another example, like find courses where teacher is team and for all students in these courses whose title is undergraduate. So we could get two tables and a relation. Students, courses, and the relation is enrollment. We could also use this way to figure it out. First step, find all students whose title is undergraduate. We could use select from student where title equals to undergraduate. And second, we could use select from courses where teacher equals to team. So we could obtain the result that select name from courses where teacher equals to team and select from students where title equals to undergraduate and not exist. Select from enrollment where enrollment as student ID equals to student ID and enrollment course ID equals to course ID. For the usage of not exists, it's only return false and true, like not exists is true if the set is empty. Not exists is false if the set is not empty. For the next common SQL operations, comparing to the binary many-to-many relationship, and there is another relationship called unary many-to-many relationship, which involves only two tables transformed. There are still two situations. Place the table transformed from the entity set and in the both and the outermost query and the middle query, or place the table transformed from the relationship in the innermost query. For the first situation, though this is a unary ER diagram, we need to create a shadow entity set. we need to create a shadow entity set and transform the unary relationship into a binary relationship. And there's an example. Find the CID and titles of those courses and use the algorithm courses as prerequisites. The first we should do is creating a shadow entity, which is the same as the courses entity, just a duplication. We could call it course 1 and course 2. And then we could use the same way to solve the problem, like the binary man-to-many relationship. The only difference is that we need to distinguish between the two attributes. So the operation is select CID and title from course 1, where not exists, select from course 2, where title equals to algorithm and not exist, where prerequisite CID equals to course 1 CID, and a prerequisite CID equals to course 2 CID. For the other situation, mostly in a query, we could only consider about the relationship inner the table, like find all employees who have no managers. It's easy to figure it out that we could use select from employees where manager EID is not, or in the opposite situation, find all employees who have a manager. We could use select from employees where manager ID is not null. And this is all I talk about today. Thank you.